I hope you're all having a great morning. I am Mr. Rich. We're looking here at two questions, both of them focusing on a specific part of a parallelogram or a specific aspect of a parallelogram. Our first question is this. We have a drawing where one of the vertices of the parallelogram is at the origin, 45 degrees away. You're looking at these lines develop. Area is equal to 10. We have to find the coordinates. You know what the four coordinates are. This, and that. We have to find these coordinates if base dimension is twice the height. The first coordinate is easy. It's 0, 0. That's done. We have to now find the remaining three. How can we do all of this? We know the area is always equal to base times height for a parallelogram, and in this instance is equal to 10. We know base is equal to 2 times height, so we can really have two dimensions, 2h and an h, the base and the height. These, if you multiply them, are equal to the 10, the area. Then you have 2h square is equal to 10 and h square is equal to 5. H is equal to root 5. If h is equal to root 5 and we know base is equal to twice the height, then we know base is equal to 2 root 5, and we have the dimensions available to us. And now let's start filling in the coordinates where we can. We know the base is this right here. It's 2 root 5 units, so therefore this must be 2 root 5 comma 0. So that's done. Now we basically have to determine these and this. We know for both of these, in terms of the x and the y, we'll have a root 5 over here because the height is root 5, so everything is root 5 units up. So we know that. We just have to determine what will be the x value here in both of these instances. If you look at this, you can draw a right triangle, and it wouldn't be a bad idea to do that and bring that right triangle out. You have a 45 degrees, you have a height dimension which we know to be root 5, and we can just calculate this dimension right here. This dimension right here is this dimension right over here, which will correspond to the x value of that unit. You can do tan 45 degrees is equal to opposite or adjacent root 5 over, let's just call that x. X is equal to root 5 divided by tan 45. Tan 45 is just a 1. So it's just going to be equal to root 5. So we know now this right here is root 5. So it's easy. Then that means the x value here must be root 5. Root 5 comma root 5. So that's good. And from there we can extrapolate that very last coordinate. Why? Because we know this dimension is root 5. We have a 45. The opposing angle here must be 45. This right here must be 135. That must be 135 because these two angles are supplementary. These two angles are supplementary. If you were to draw another right triangle up right here, this dimension here to here would be exactly root 5. So you'd be 2 root 5 plus root 5 units away, and this would be 3 root 5. 3 root 5. If you didn't catch that, we're right here at an x value of 2 root 5. But we know from here to here we have another root 5 units away, because for each of these right triangles, the base is always root 5. And when you add these, you get 3 root 5, and that falls right there. 0, 0, 2 root 5, 0, root 5, root 5, 3 root 5, root 5, and that's it. Those are the coordinates which have been completed for you. Our second question is this, very well in line with the other one, but we have to do contrasting here. We have to contrast a parallelogram where base is equal to height. In the previous question we had base was equal to twice the height, meaning the base was twice the dimension of the height, but the area is the same. Now look how things will radically change over here. In this instance, you know base is equal to height, and base times height is always equal to the area, which here in this instance is equal to 10. You can do b times b is equal to 10, or you can do h times h is equal to 10, b square is equal to 10, h square is equal to 10, b is equal to root 10, h is equal to root 10. And now if you were asked now to determine the coordinates of all of these, you can do that, but the values will be quite different. This right here will be the same, of course it's 0, 0. And we know again we have an angle here 45 degrees, and now look how things will play out. From here to here is your base, here to here is your base. If base is root 10, this must be here root 10, 0. But we know height in all instances are root 10. So this right here will have a root 10. And this right here will have a root 10 in terms of the y value. We have to find the x value in both instances. If base is equal to height in all instances here, base is equal to height, root 10 is equal to root 10. When you're coming here to root 10, you know the height is root 10. You're gonna very well fall in line with this vertex right over here. because the base dimension was equal to height dimension, this right here must be equal to root 10. In all instances, x is always equal to y. You can extrapolate everything over here, because however much you went out here to this coordinate, that will very well fall in line with this coordinate here, because again I'll say base was equal to height in all cases. So this must be root 10 comma root 10. If base is equal to height, then you must be root 10 units here again out here. So you must be root 10 plus root 10, and that would make you 2 root 10, and this coordinate here would be 2 root 10 comma root 10. And if you were to check everything here to be true, you could pluck out one of these right triangles, and you know you were looking at 45, 45. The height here is root 10, we have a 45. Just do tan 45 is equal to this height root 10 divided by this base right over here. And base over here would be root 10 divided by tan of 45, but tan of 45 is 1, which is just root 10. So you know you'll end up getting a root 10 over here. Now I'll erase this and we'll pluck out this other triangle, which is this upside down triangle, and it looks like this. We know here it's root 10, but we know here again it's 45. You can do tan 45 degrees. With respect to this, it's equal to opposite over adjacent. It would be root 10 over x. Here x again would be root 10 divided by 1, which is root 10. So you know again you're root 10 units away in this direction. From your origin, you're root 10 units in this direction, hence you have root 10 comma 0. From this point, you're root 10 units away again from this coordinate, so you're root 10 plus root 10 to root 10 in terms of your x values, which is why this specific parallelogram is vastly different than the previous one. If you were to draw it out, look at it, you're looking exactly like this, something like that, and then like this, right over here, exactly where your this base ends, your base continues from there. Contrast this to this type of a parallelogram where you have a pretty long base and a pretty short height. In this instance, you have quite a bit of overlap. You see there's quite a bit of overlap over here of your base. This much over here to this much over here is your base overlapping. When you're looking at this type of parallelogram where the base is equal to height, there is no overlap of the base. The base ends over here and then it continues onwards from a certain height away. You see that, right? There is no overlap over here of the base, but there's a significant overlap over here of the base, and that right there is the difference between the parallelograms where the base is equal to height versus here where the base is quite a bit times the height in terms of the dimension, whereas where the base is significantly larger than the height in terms of dimension. But that's the end of this specific video. The coordinates here are developed and they should be all good. Have a great day. Bye.